All right, guys. So here we are. We have a word problem, guys. Now, when you're working with the word problems, it is critical for you to read your word problems at least twice, guys. Why? Because the first time you read it, you are in shock. They're asking you to find the answer to this problem. It's the second time you read the problem and you're like, oh, wait a minute, I actually have to find an answer. So let me get this thing together and figure out a solution to this problem. Now, so that's the first thing, guys. You need to read your word problems at least twice, okay? At least 2 times. Now, because you're going to be doing the Algebra and EOC on the computer, you need to make sure, yes, Sugar Plum, you can write on there. Okay? You need to understand, guys, you can write on the screen, just like, I don't know who just did it, but someone just wrote on the screen. Yes, you can annotate. That's what we call annotate on here, guys. You can annotate. So since you guys can annotate on here, personally, I would underline, I would highlight on the computer screen just to make sure I have a pretty good idea of what I'm working with and what kind of plan I need to come up with to be able to come up with a formula, come up with a plan to solve this word problem, guys, okay? And as I mentioned to Marsha before and everybody else, the best way to learn how to do word problems is to actually get in there, guys, and practice with the word problems. You want to become great at word problems, practice with the word problems. When my students are in my classes, guys, let me tell you, every assignment has word problems. Sometimes I give them an assignment, it's all word problems because I want them to feel comfortable with word problems. At the beginning of the school year, they complain, oh my God, it's a word problem. But now, listen, they're fine, they're fine. All right, guys, so here we go. Remember, guys, when you're reading these word problems, they always put extraneous information in there. Extraneous information is just information that is really not needed, guys, for you to be able to solve the problem. Okay, now why can't I write on here? Okay. It's not allowing me to write on here, guys. Let me see here. Hold up a second. I know I can write on here. All right, so there we go. I think this will do it. All right. So guys, here we go. So on this problem here, it says the aircraft A330 flies. Okay, so you don't need to know the name of the aircraft. That's extraneous information. On average speed of 500 miles per hour. This information right here you need. That's critical information, okay? That you need it, okay? Next, the expression 500 times t. 500 times t gives the distance, tells you how far the plane travels in t hours, x hours, t hours. Find, what are we looking for? We're going to find the distance traveled by the 800 and 330, A330 in 3 hours. So guys, what do they want us to do? They want us to find the distance. How do we find the distance? They gave us a formula to calculate the distance. It's right here, guys. 500 multiplied by t, okay? That's how you calculate the distance. 500 times t. What does the t stand for? The number of hours or the length of time that this plane has been flying. So if the plane has been flying in for 3 hours, guys, how far has it traveled in the 3 hours? What distance has it covered? So you take the 500 miles per hour and multiply it by the 3 hours. Now, guys, listen to this one. If you had no clue how to do this, here's something else you could do, okay? And you do not have to use a formula to come up with this. You know, every hour the plane goes 500 miles. That's the first hour. That's the first hour. Hour 1, 500 miles. Hour 2, 500, another 500 miles. Hour 3, another 500 miles. And then you can ask yourself, altogether, how many hours is this right there? How many hours? That's 1,500 miles right there. Okay, guys? That is common sense. Why do we do word problems, guys? What is the purpose of mathematics? The purpose of mathematics is to make you think critically, to problem solve, okay? Figure out the solutions to these problems by thinking critically and using logical reasoning skills. That's all it's about, okay? Right now, guys, I'm going through the problem, but I am going to be asking you questions too. So just get ready, people. I am going to be asking you some questions, okay? So let's move on to the next one. Oh, wait a minute. I have to navigate it over here. Yeah, I have to control that part. Okay, guys. All right. So this one right here, it looks intimidating. But guys, really, let's decipher through this. What do we really need? Okay, let's look. Employees at Al's supermarket constantly reorganize and reshelve merchandise. You don't need any of the first sentence. Bam, gone. In doing so, they calculate floor space needed for displays. Okay, fine, they're going to calculate floor space. Bam, we don't need that either. The algebraic expression, now we're getting into something we need. L times W, you can even rewrite it, L times W, gives the floor space needed in square units for a display that measures length L units and width W units. Calculate the floor space needed for a display whose length is 6.9 feet and whose width is 2 feet. And what do they want us to calculate? The floor space. How do you calculate the floor space? You multiply the length times the width. That's a formula, guys. What is that formula going to calculate? It's going to calculate the area. Oh, look at you guys go. Nice, nice. Ah, look at you, very good. Normally the name pops up on here for me. Why isn't the name popping up on here for me? Who's doing the problem on the screen?
That's me.
That's, I love it. Marsha's like, I got this one, lady. I got this one. Okay, guys.
It's not Marsha. It was not me.
Oh, that was Mimi? Sorry.
Oh, wait. That wasn't Marsha. It wasn't me. It wasn't me.
Okay.
I thought you was calling my name.
So who was it?
It's Isabel.
Oh, Isabel. Excellent. But Marsha, did you get it?
I understand these types. It's just those more hardcore ones. Like, how can I say? It's like they're asking for the expression and they use words that are not that easy, like length times width. That's easy stuff. I think they like I think
like
they
something like this one?
they 5 more twice the number. It's kind of like that, but it's more harder. I have to find it through one of my grades, but when I find it, I'll tell you.
Okay. Would you be able to do something like this?
Kind of, maybe. I have to work it out first.
Okay. All right. So on this one right here, guys, they're just asking you to write the phrase as an algebraic expression. So you're just rewriting it as an algebraic expression. That's all. They're not asking you to solve for anything. Now, they want you to use X as the variable. Who can express this for me as an algebraic expression? If you can put it on the screen, you're welcome to. Or you can tell me or drop it in the chat, guys. Anybody? Okay. So since I'm not getting anything from anyone, then let's go over it, guys. Oh, here comes somebody. I don't know why the names are not popping up today. Normally the names will pop up, guys. Nice. Is that a question mark as in I'm not sure this is the answer I have? Is that you again, Isabel?
Yes, I'm not sure. I just wanted to try.
Okay, Ms. Vega, you almost got it, sweetie pie. You got your 5 in there. Okay, that's your 5. More than means addition, Ms. Vega. You got that. But then, Ms. Vega, it says twice a number. When it says it's twice a number, okay, what comes to your head about twice a number? A number is X, but what about the twice part? What does that mean? What does it sound like? Does it sound like an operation? Does it sound like a number? What does it sound like?
A number.
A number, what number?
2.
2, okay? So that's all it is, Miss Vega. Twice X, you just needed to make sure you included that in there. And just like that, you have your expression, Miss Vega. Okay? So make
Okay.
sure, guys, you're reading it carefully. Alicia, I'm seeing you. Okay, you're saying square 5. Okay, so let's go over a couple of things here, guys. So the word twice, let me erase some of this, okay? So the word twice means 2 times. There's another weird one you guys might not see. Thrice. Thrice. That means 3 times. If it says 4 times, that's very clear. 4 times, 4 multiplied by something, okay? But guys, you gotta be careful with this. You gotta know the terminology. Twice a number, thrice a number. Twice and thrice sound almost exactly the same, but no, they're not the same, guys. So be careful with that. If it says to square a number, that's a power, guys. So you would have something like this, like 3 squared. That's square a number. Now, on that note, if they say the square root of a number, we'll be looking at something like this, the square root of 9, okay? Now, another one they might say is cube the number. When they're talking about cubing a number, they're talking about raising it to the 3rd power, okay? Now, if they say the cube root of a number, then you're looking at taking a root, but rather than doing square root, you're going to do the cube root, okay? Now, cube involves a multiple of 3, guys, multiple of 3. So cube root is taking the radical or the root of a number, but because it's a multiple of 3, you have to make sure, guys, inside that radical, you include that. All right, so I am seeing something here. Let me see what I'm seeing. Mrs. Mendoza is organizing seating for a standardized test. 45 ninth grade students and 110th grade students will take the test. Each row will have the same number of students, but 9th graders and 10th graders will not be seated in the same row. If she puts the greatest possible number of students in each row, how many rows will there be? This type of I got you. All right. So she's got 45 ninth grader and 120 10th graders, okay? So right there, that's critical. I'm gonna write it down on here because obviously I cannot write on your note there. 45 ninth, and then the 10th graders, okay, is 120. All right, so now guys, it says each row will have the same number of students, okay? Each row has to have the same number of students, but 9th graders and 10th graders will not be seated in the same row. So which means you cannot mix the 9th and the 10th graders in a row, okay? So let's say you have a couple of rows. You have to have 10th, 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 okay? These are columns, by the way. And then 9th, 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 and so forth and so on, guys, okay? So now, let me see here. I have to erase some of this because I'm covering the problem. Okay, so now will not be seated in the same row. If she puts the greatest possible number of students in each row, how many rows will there be? The greatest possible number of students, guys. Okay, now there's an operative word in there. Unfortunately, I cannot write it on, you know what? Maybe I can. Hold on a second, guys. Let me see if I can grab my pen and write directly on here. Let's see if it works. Oh, it might work. The greatest possible number of students right here, guys. You see that? That word greatest is what you need to pay careful attention to, okay? The greatest possible number of students, as in the largest possible, the most possible. So in this one, guys, you really have to look at your 45, the number 45 and the number 120 and see what they have in common. So in other words, you have to prime factor these numbers. Prime factor these numbers. Prime factor them. And so when they talk about the greatest possible number of students like that, Sweetie Pie, the greatest number possible has to do with a GCF. Have you guys ever heard about the GCF? Have you guys heard of GCF, greatest common factor? Have you guys done that before?
Yeah.
Yes.
Okay, perfect. So here's what we're going to do. We're going to prime factor 45. You guys know how to prime factor? Do a prime factor tree? Yes?
Yeah.
No?
Yes.
Okay. All right. So who can give me the prime factors for 45? Anybody? Drop them in the chat if you don't want to speak. No? All right, guys. So let's do it together then.
Isn't it 3 and 5?
Not just 3 and 5. Here, I'm going to tell you why it's not just 3 and 5, Sugar Plum. You're close. Because if you multiply the prime factors together, it has to take you back to the original number. If you multiply 3 times 5, you're going to get just 15. You want to get back to 45. But you're almost there, Sweetie Pie. If we
Isn't it?
Uh-huh.
Oh, it's 1, 3, 5, 9, 15, and 45.
Okay. Oh, I hear you, Sugar Plum. But we're talking about prime numbers. What are prime numbers? Those numbers that have only 2 factors, 1 and itself, okay? So prime numbers are numbers like 2, 3, 5, 7. They only have 2 factors. They have a factor of 1 and then the number itself, okay? So you can't count a number like 6. 6 would not work because 6 has the factors 2, 3, 6, and 1. That's 4 factors. Now, a prime number has 2 factors, 1 and itself, okay? So when you're prime factoring 45, you basically take the 45 and break it down into 5 times 9, and 9 is not a prime number, so you break it down some more. So these would represent the prime factors of 45. 3 times 3 times 5. Now we're going to do it for the 120, okay? So for 120, Sweetie Pie, you can, by the way, this is called a factor tree, Sugar Plums. I'm sure you guys have heard of a factor tree. That's a factor tree. So now we're going to factor tree the 120. Let's factor tree 120, guys. Factor tree the 120, please. Let's see what we come up with. All right. So 120, what 2 numbers multiply to give you 120? 10 and 12, 12 and 10. It doesn't matter which 2 you choose. Is 10 a prime number? Can we find 2 numbers that multiply to give us 10? Absolutely. 2 times 5. 12, what are 2 numbers that multiply to give us 12, guys? 3 times 4. 4, what are 2 numbers that multiply to give us 4? 2 times 2. You see that? Okay, guys, so now we're going to list the prime factors. 2 times 2 times 2 times 3 times 5. All right, guys, now we circle what they have in common. What do they have in common? A 3 and the 5. And so if you multiply the 3 and the 5 together, this would represent the largest number of students. That must be in each row. Okay? So guys, if you have 45 ninth graders, how many rows of 45 ninth graders will there be? If you have 45 ninth graders and you're going to break them up into rows of 15, how many rows would you have, guys? Come on, Sugar Plums. No?
Wait, what's the question?
The question is, if you have 45 ninth graders, each row has to have 15 ninth graders in it. How many rows of ninth graders are you gonna have?
3.
3, absolutely. Now, let me see here. Hold on a second. All right. I forgot who just said that. Someone just said that. But listen, guys, when you say it with confidence. Don't doubt yourself, Sugar Plum. Even if you're wrong, say it with confidence, okay? The answer is 3. 3, okay? Say it with confidence. Don't put a question mark on there, Isabel. Just say it with confidence. Even if you're wrong, Sugar Plum, okay? Pretend like you're right. Even if you're wrong, say it with confidence, okay, Sugar Plum? All right. Now, I don't have to usually tell my guys that, but my young ladies, I constantly have to remind them, guys, when you do these problems, do it with confidence. Do it like you know what you're doing. You do it with a lot of confidence when you give these answers. Okay, guys. So yes, there's going to be 3 rows of ninth graders. All right, guys. What about the 10th graders? There's 120 10th graders, and we're going to separate them into 15 in a row. Each row will have 15 10th graders. So how many rows of 15 are we gonna have if we have 120 10th graders, guys?
5.
5?
It would be 8.
It would be 8. But, oh my God, Mimi, I want you to hear this. Did you hear how Brendan said that answer, Mimi? And Mimi's like, 5? Brendan's like, 8. Okay? Mimi, that's what I'm talking about, okay? Say it with confidence, ladies, okay? Confidence. But, Brendan, can you tell us how you got the 8?
You would get 8 due to 120 being a multiplier of, well, 12. You would break that into parts, looking for what would be the closest. Okay, how many would go into each group? So 120 would go into 8 different groups if you're going it by. Sorry if I'm not good at explaining things too well.
You're doing great, man. You're doing great.
120. It would pretty much the easiest way to say is for 120, due to it being a 12, being a multiplier of 12, you would dividing 120 by 15. Like I said, would equal 8 groups. 15 being 120. I got off track and I forgot what I was going to say.
You're doing great, man. You're doing fabulous, okay? Keep going, okay? Listen, let me just clarify something to you, okay? Because you sound like you were doing just fine. You just needed a little bit of clarification. Now, guys, my screen is acting up. I'm not sure if we're gonna have everything on here once I'm done, but I'm just letting you know, just informing you, my screen is acting up, so I might not have a recording for you, but we're gonna keep going, guys. We're gonna keep going, okay?
Yes.
Yes.
I'm gonna go to the bathroom. I'll be back.
Okay, that's fine, Sugar Plum. All right. So guys, listen to this. So you got 120, Brendan. And yes, Brendan, you do divide it. Now remember, we originally stated that each group will have 15 students, Brendan. So essentially, Brendan, you're taking that 120 and you're dividing it by 15. So you're going to create 8 groups of 15. Now, I think what you were trying to say by splitting up the 120 is that 120 can split up into 60 and 60 because 60 plus 60 is 120. Does that make sense, Brendan? Okay? And so once you break it up into 60 and 60, you know each 60 must have how many?
You're muted.
Yes, we're back. I was having some connection issues here. We're back. All right. So let me just pull up the whiteboard here because I'm going to have to go back and pull up the other part. Okay, there we go, guys. Okay, so this is what we're talking about. Brendan said, all right, here it is. Brendan said, I took the 120 and I split it up into 2. So I've got 60 and 60, okay? Remember, guys, each group must have 15 students, okay? 15 10th graders. Now, the 60, you can split it up even further, okay? 30 and 30, guys, okay? So if you split it up further, 30 and 30 for each group of 60, then you take each group of 30 and you split them up into 15 and 15 for each group of 30, guys. And how many of them do you have? You'll end up with a total of 8 of them, guys. And there you go. But Brendan, you don't even have to do all of that, Brendan. You can just do a quick division problem by taking the 120 and dividing it by 15. And this will give you the 8 rows of students you're going to need. On your calculator, well, actually, you guys might not be able to do this on a calculator. You're just dividing, sweetie pie. And I know, I hear you guys. If I don't have a calculator, how do I divide this without a calculator? Can I do this without a calculator? Yes, you can. How do you do it without a calculator? Take that 120, break it into something familiar. Like 120 is 60 times 60 plus 60, like Brendan was saying. Can you guys do 60 divided by 15? Are you able to do that? Can you guys do that? No? You guys
Or you can do the long-term division.
You can do long division?
Yeah.
Okay. Let me show you something else you guys can do. Remember how we prime factor the 120, guys? We prime factored it. So let me show you one other way you can approach this. If you're taking 120 and you're dividing it by 15, guys, look, you can break up 120 into 12 times 10, and you can take 15 and break it up into 3 times 5, because those numbers are familiar to you. 3 goes into 12, 4 times. 5 goes into 10, how many times? 2 times. 4 times 2, right there, 4 times 2 gives you 8. You see that? So you don't have to sit there and do long division, Sugar Plum. No, Sugar Plum, this is gonna take too long. No, 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 Sugar Plum. Is that what you guys are doing in class, doing long division?
We usually use our calculators.
Okay. Well, do you guys know there are parts of the test where you cannot use a calculator?
Yep.
All right, very good. All right. So, Marsha, how do you feel about this problem, Marsha? Talk to me. Talk to Miss Oxer.
I feel fine now that I understand.
Now, the question is going to be, Marsha, if you see another problem similar to this one, are you going to be able to do it?
Yeah.
You sure? Okay. Now, Marsha or Mimi, listen, Sweetie Pie. Go with confidence. You can do this, okay? I think part of the reason why you keep doubting yourself that you cannot do this word promise is because of the confidence level. It's like somebody's told you somewhere along the line you can't do these word problems, or maybe you told yourself that you can't do them, and you've always felt that way. You've always believed that. So when it comes to word problems, once you see a word problem, sometimes students have a tendency to panic. They panic thinking the problem is difficult. But if you take the time out, Sugar Plum, and actually read the problem, once you read it, you might feel more comfortable with the problem, and you might be able to do it because you feel more comfortable with the problem. So listen to this, Sugar Plum. Just know you have the knowledge, you have the background information to be able to do these word problems. So just make sure when you go into these word problems, you keep reminding yourself, I can do this, I know how to do this, I am going to do this, I can figure out this problem. Now, for everybody, listen up, Sugar Plums. Once you find your answer to a word problem, you're not done. You need to go back and reread the question to make sure you've actually answered the question you set out to answer. Now, for this particular problem right here, it's gone from the chat, guys. I think the actual question was, how many total rows are going to be there, okay? So we did the ninth graders. The ninth graders ended up with 3 rows, okay? We did the 10th graders, and the 10th graders ended up with how many rows? 8 rows. So if they want the total number of rows, we're gonna have to add this together and get 11 total number of rows, people. Yeah. So this is another reason why it's critical, guys. When you find your answer, you don't stop there. You need to go back, read the question to see if your answer makes sense within the context of the problem and to see if you actually answered the question, guys. What was the question again, Marcia, since we're having technical issues? What was the question again? Do you remember?
Yeah,
What did
it was Mrs. Mendoza is organizing seating for a standardized test. 45 ninth grade students and 120 10th grade students will take the test. Each row will have the same number of students, but ninth graders and 10th graders will not be seated in the same row. If she puts the seated in the same row, if she puts the greatest possible number of students in each row, how many rows will there be?
Mm-hmm. Okay. How many rows will there be, right?
Yes.
Okay, 11 rows, okay? Because you have to take the number of rows from the ninth grade class and the number of rows from the 10th grade class and add them together so you get 11. Yeah. All right. Isabel, I think I saw your hand. It went up. So ask me a question, Isabel.
It's not really a question, but yeah, it kind of is. But when does this class end? Because I have to eat dinner soon.
Oh,
so
you can go, Sugar Plum. You can go. I think the recording will be okay. And so I'm going to pop up the recording because I think somebody was asking questions about graphing the quadratics. I don't remember who, but somebody was asking the question. Who was asking the question about graphing quadratics? Was it you, Isabel?
Milana, I think that's her name.
Okay.
I think Milana.
Milana? Okay, thank you. So Isabel, if you have to go for dinner, girl, go eat your dinner with your family. Good for you that you eat dinner with your family. That's awesome. I asked my students that question the other day. Do you eat dinner with your family? No, Miss Salsa, we go to our room and sit in our room and eat dinner. Eat dinner with your family, Sugar Plum.
I
Anyway.
hope you have a good day.
All right, Isabel. Thank you so much for attending. Enjoy your dinner.
Bye.
All right, bye-bye, bye. Okay, guys, so let's talk a little bit about graphing the parabolas, okay? Because I know somebody wanted me to go over that. Let me see. Milan, you still there? Okay, Milan, here we go. All right, I don't know exactly what you guys need to know about graphing of the parabolas, but I'm going to do 2 examples, okay, guys? So here comes the first one. F of x is equal to negative x squared minus 4x plus 5. All right? Now, this one right here, guys, is called the general form. When we talk about the general form of the quadratics, or the general form, guys, of these second-degree equations, we have to do a lot of work in order to be able to graph it. So, guys, let's see if you guys remember any of this from last week. Which direction is the graph going to open? Anybody remember? You can type it in the chat or you can turn on your mic and talk to me. Which direction is it going to open, guys? Anybody? Come on, sugar plums, you can do this. Okay, seems like some of you don't remember. So let me go over this. You need to look at your x squared, guys. Look at the coefficient. Look in front of x squared. If the x squared is positive x squared, it's going to open up. However, if your x squared is negative, it's going to open down. So if the leading coefficient, if you look in front of x squared, you have a negative, it opens down. If it's positive, as in there's nothing there, it's going to open up. So guys, this one right here is going to open down. Now, the next part of this is the graphing of the y-intercept. Now, the y-intercept, guys, is where the graph intersects the y-axis. To find the y-intercept, you take 0, go back into the function, plug it in for every single x. So guys, pay attention. Look up at this, okay? So if I go in here and plug in 0 for this x, it cancels out. If I plug in 0 for this x, this also cancels out. What am I left with, guys? Drop it in the chat. What am I left with? You can drop it in the chat.
5, your C.
Yeah, my C value, 5, okay? So guys, there's my y-intercept. Now, whenever you're graphing, typically you are required to have at least 2 points. So having the y-intercept there, guys, that's 1 point, okay? So let me go back just slightly. All right, there we go. Okay, so we got our y-intercept. Now, the most important point on the graph of a parabola is the vertex, guys. The vertex is the turning point. So the graph is going to look like this, guys. The vertex is going to be up here, okay? That's the most important point on the graph of a parabola. How do we find the vertex? Well, to find the x value of the vertex, we're going to use this little formula here. The opposite of b, the negative means the opposite, of b over 2 times whatever a is. Now, in this quadratic equation, guys, your a value is -1, and your b value is -4. So we're going to plug them into the formula. So we get x equals to the opposite of b. B is -4, so when you do its opposite, it's going to become a +4 over 2 times the a value, which is -1. So 4 divided by -2 leaves you with -2. So now, guys, you have the x value of the vertex. It's time to go ahead and find the y value. And guys, to find the y value of the vertex, listen to this, everybody. You take the x value, which is -2, go back into the function and plug in that -2, substitute the -2 in for every single x, guys. Every single x. Every single x, okay? Substitute that value in, +5. Okay, and then you're gonna work it out, guys. So I'm gonna bring down this negative. -2 squared, that's 4. -4 times -2, guys, that's +8. And then -5. -4 plus 8 is 4. 4 minus 5, I mean +5, it's supposed to be a +5. I don't know why I'm saying -5. 4 plus 5 gives me 9, guys. So guys, that's the y value of the vertex. So now we have some really good points on the graph of the parabola. I'm gonna erase some of this, guys. I'm gonna erase some because I think it's a little too messy. So let me erase some of this, okay? I'm gonna put it back up. F of x equals to -x squared minus 4x plus 5. We said the graph is going to open down. It has a y-intercept at 0, 5. And then the vertex, guys, is at -2, +9. Now, guys, listen to this next part. We need to know the axis of symmetry. Does anybody know what the axis of symmetry is?
-2.
Oh, very good. All right, Marsha. The axis of symmetry, guys, first and foremost, it's an equation, okay? It goes straight through the middle of the graph, intersects the graph at the vertex. So basically, it shares the same x value with the vertex. So since the vertex has an x value of -2, the y value, the axis of symmetry is also x equals to -2. So to graph this one, guys, we're just going to go to the XY plane, okay? I am always going to plot my vertex first, guys. I like plotting the vertex first, okay? So I'm gonna go to the XY plane here, find my vertex coordinate. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's a -2, -2, 9. That's the vertex way up here, guys. Then I'm gonna plot my y-intercept at 0, 5. 1, 2, 3, 4, 5, bam. So guys, the graph is looking something like this, okay, on the right side. So how do we determine which way the graph is heading on the left side? So here comes the line of symmetry. The line of symmetry goes straight through the middle of the graph, intersects the graph at the vertex. Whoops, it's supposed to intersect that -2. So guys, this point right here is 1, 2 units away from the line of symmetry on the right. So you count 1, 2 units to the left side of the line of symmetry, and then you reflect this point right here, guys. And so now you have 3 good points on the graph. And so this is what your graph looks like. Now, let me just say this, guys. Notice the axis of symmetry is an imaginary line. Why? Because it's not supposed to be part of the graph, guys. That's why it's an imaginary line. So this is what the graph looks like. Now, any questions? Okay, I'm not done with you yet, guys. I'm not done with you. There's more. Okay. So here's the next part, guys. Does this have a max or min value? Does it have a max or does it have a min value?
Max.
Very good, Mimi. Okay, I like how you're starting to say these answers with a lot of confidence, Mimi. I'm liking that. That's a maximum. That's a maximum. Excellent. Okay. Now, guys, when we talk about the maximum, remember the maximum is the highest point on the graph. In particular, we're looking at the y value at the vertex. So in this one, if they were to ask you, what is the maximum value? The maximum value would be the y value at the vertex. What's the y value at the vertex? 9. The maximum value is the highest point on the graph. Now, guys, here's another big question for you. What is the domain of this function? What's the domain? All of you should know that because yesterday when I was talking to the other group, everybody knew this one. What's the domain for this one, guys?
I don't know if I'm gonna say it correctly, but negative of infinity, comma, positive infinity.
Oh, okay. Okay, Mimi, I see you. Mimi, that's advanced level stuff, okay, Mimi? All I wanted to hear from you was all reals, but here you are giving me the information in interval notation, negative infinity to positive infinity. Is that what you guys, how you guys are learning to do it in class? Because I didn't do it like that with the other group. Or is this something that I showed you guys last week? I don't know.
No,
What
we do all real numbers as well, but I find it a lot easier from the other subjects we did.
Okay, from negative infinity, positive infinity. Very good, Mimi. Very good. I love it. Great. So guys, yes, the domain is all reals. I think for Algebra 1 you'll see, because they haven't discussed interval notation in Algebra 1, they want you to know that the domain represents all reals, as in you can plug in any x value in here. It includes all x values, positive, negative, and 0. Now, here's the hard part, because I was speaking to Miss Patterson. Miss Patterson said, you know what, Alcira? This is what they're having trouble with, the range, finding the range. So does anybody know what the range of this problem is?
Parentheses, negative infinity, comma, 9 with the bracket.
Negative infinity, comma, 9 with the bracket. Mimi, are you sure you're in 9th grade or are you in 10th grade?
I'm in 9th in Miss Patterson's class.
Wow, Mimi, you're doing fabulous, girl. Listen, I've got seniors who can't tell me that, okay? Okay. So listen, guys, when you go to the Algebra 1 EOC, they may not express it this way. You have to know what the inequality looks like, okay? The range has to do with the y values, guys. The y values represents the vertical part of the graph. So since the largest point, the highest point on the graph is at the vertex, okay? So basically, the largest possible y value on this graph is at the vertex, and it's going to be positive 9. Everything else is below the positive 9. Everything else is less than the positive 9. So if you had to express this, guys, as an inequality, it would be y is less than or equal to positive 9. Now, what Mimi gave us, guys, is what we call interval notation. And interval notation is another step, another way to express an inequality, guys, okay? That's just another way. But for the algebra 1 AOC, you guys got to know y less than or equal to 9. Every y value less than or equal to 9 would be the range of this parabola. All right, guys, we are making great progress. So I am exceedingly proud of you guys. Now, let me just do this one more problem. And I want you guys to tell me if you are comfortable with this format right here, because I'm not sure what you guys are learning in class if you've already gotten to this part of the class yet. Okay, this form right here, guys, is called the standard form of a quadratic. Have you guys seen this form before? Sometimes I like to refer to it as the vertex form. Have you guys seen this form before? Because I don't want to go too far ahead.
Not really.
Okay.
I have.
You have, JD. You have Miss Dennis, right, JD?
Yeah.
Okay, perfect. And by the way, guys, the video last night includes, I think 3 or 4 examples like this, but I'm only going to do this one example with you guys because I don't want to keep you for that long. All right, I've already kept you long enough. The standard form, guys. Why do I call it the vertex form? Because you can actually eyeball this and figure out the vertex, guys. You don't have to do any work to find the vertex. You can just look at the equation and find the vertex. Now, this form, the standard form, the general standard form looks like this: x minus h squared plus k. So basically, when you're finding the vertex, guys, you want to do the opposite of the number inside the parentheses and then the number on the outside. So if you go back to this equation that I gave you, this one right here will have a vertex at the opposite of what's inside the parentheses, -2, comma, the number on the outside, -3. So guys, no work required. And just like that, you have your vertex at -2, comma, -3. All right, guys. So here's another question for you. Is the graph of this parabola going to open up or is it going to open down, guys? Remember, I showed you earlier how you determine whether it's going to open up or down.
It's going to open up.
Very good, Mimi. I love it. You hear that confidence? I love it when you say it to me with confidence. Awesome. Yes. How do we know it's going to open up, guys? Because you look in front of the x squared term. If it's positive, yes, it's going to open up. All right, guys. Now, here's another big question, okay? What is the equation of the axis of symmetry? What's the axis of symmetry, guys? For this problem, what would be the axis of symmetry? Remember, it's an equation. X equals to?
X equal negative. Yeah, -2.
Very good. I see you, Elisha. Very good, guys. Excellent. All right. So here's a follow-up question, guys. Does this one gonna have a max or min? Will it have a max or min value? Ooh.
Max.
Ooh, Elisha says max.
Min.
Min. Mimi says min. Who's right? Well, guys, listen. I didn't give you the graph, so you could not use the graph. So, guys, this is where critical thinking skills come in. Okay, now let's think. If the graph opens up, where am I going to find the vertex? Am I going to find the vertex at the bottom, or am I going to find it at the top?
Bottom.
At the bottom, JD. So if it's at the bottom, is that going to be a low point in the graph or a high point in the graph? Yeah, it's going to be at the bottom. And so because it's going to be at the bottom, it's going to be the lowest point on the graph. So therefore, it must be a Minimum, guys. All right, here's the last question I'm gonna ask you guys. By the way, the minimum, remember, is the y value at the vertex. So the minimum here would be a -3. Last question I'm gonna ask you guys. What's the range for this one, guys? What's the range? Give it to me as an inequality. What's the range?
Y greater to equal to -3.
Y greater than or equal to -3. Excellent, Mimi. Mimi, you got this, girl. You got this. You guys have it. Okay. So Mimi gave me the inequality to represent the range, guys. Remember, -3 is the lowest point on the graph. So everything else must be above the -3, must be greater than the -3, bigger than the -3. So that's how you determine your range. So guys, I am going to stop right here because I've taken too much of your time today.